We start by talking about Markov inequality. So consider a random variable x, and this random variable is positive, so it takes only values greater than 0. So then for a given constant a greater than 0, we have probability that this random variable x takes on values greater than a. This is less than equal to expectation of random variable x divided by the constant a. Now to prove this, we first define an indicator function. So the indicator function is it takes on value 1 if the random variable is greater or equal to a, and it takes a value 0 otherwise. That otherwise means if the random variable is less than a. Now the beauty of this is that expectation of the indicator function in this case is probability that x is greater or equal to a. Now this follows just from the definition. Now if it is indicator function, you can see that you multiply by 1 and you sum up the probabilities, and the probabilities you sum up only for those values of x where the random variable is greater than a. So when you sum it up, you just get probability x is greater or equal to the constant a. So you have this indicator function is either 0 or 1. So it is less than equal to 1. So indicator function is either 0 or 1. Now this equation immediately implies that x by a is greater or equal to 1. So that is how we get this. Now you take expectation on both sides. You take expectation here and expectation here. You get expectation of indicator function is less than equal to a is a constant, so it filters out. This is less than equal to expectation of x divided by a. So expectation of I is this. So probability that x is greater or equal to a is less than equal to expectation of x divided by a. Now we talk about Chebyshev inequality. So now again you consider a random variable x. Now we are not imposing any condition on x. So we are not saying x should be positive here. And the expectation of x is given to be mu, and the variance of x is given to be sigma square. So then we have probability that absolute value of x minus mu is greater or equal to some constant c is less than equal to variance of x divided by c square. So first notice that this condition holds, that is x minus mu square is greater or equal to c square if and only if x minus mu is greater or equal to c. Now since x minus mu square, this is a positive number, so you can say x minus mu square is itself a positive random variable. So now we can apply Markov inequality here. So instead of x, we are going to write another random variable which is x minus mu square. So and instead of a, we are going to write c square. So instead of a, we write c square. So x minus mu square is greater or equal to c square. This is less than equal to expectation of the random variable, that is x minus mu square. Now this is just the variance, because you know the variance is expectation of x minus expectation of x square. So this is the variance. So instead of expectation of x, we have mu. So the probability, so x minus mu square is greater or equal to c square if and only if x minus mu is greater or equal to c. That's what we write here. So probability that x minus mu is greater or equal to c, this is less than equal to, you have variance here, this is variance of x, which is sigma square divided by c square.